Okay, so here's another log problem that popped up on the final. This is log base 6 of x minus 5 plus log base 6 of x is equal to 2. And you need to know one property of logs to be able to do this in addition to what you already know about logs. So let me show you my solution here. I start at the top. Log base 6 of x minus 5 plus log base 6 of x is equal to 2. Now, the property of logs I'm talking about is that if you have two logs of the same bases and you're adding them together, that means that you can multiply the things that are being logged together under a single log. So this really is just equal to log base 6, right? And then you have x minus 5 and x getting multiplied together. That's not a multiplication, not a subtraction, being multiplied together inside of a single log base 6. And the reason is that's the corollary of the exponent rule, that when you multiply two things together, you can add the exponents. So logs, really, when you log something, you're generating an exponent. So if you're adding two exponents together, then you can multiply the two things together that are being logged. So yeah, if you want, I can actually show you the rule and why it works given the exponent rules. But for the sake of this demonstration, I'm just going to continue here. Now what I did inside is I just multiplied x minus 5 times x. I got x squared minus 5x. And that just happened inside of the log. Okay. Now here's that, remember exponential, exponential functions and log functions are inverses of each other. So the way to get rid of a log on a problem is to put both sides of the equation above the base of the log. So I'm going to, it seems weird, but I'm going to take this side and this side, and I'm going to put them both above a base of 6. Okay. And what this will do for me on the left side is that, and whenever you have 6 to the log base 6 of something, really you just wind up getting whatever is being logged, x squared minus 5x. Okay. Now over here, 6 squared is just 36. That's just arithmetic. Now you've got an equation that doesn't have any logs in it. You still have to know how to solve this. This is a quadratic equation, so our intuition there is always to get the 0 on one side by subtracting 36. You could use the quadratic formula or completing the square here. This one happens to be factorable, which always makes solving the quadratic equation much quicker. So we get x minus 9 is equal to 0. And we get x plus 4 is equal to 0. And this means x is equal to 9 or x is equal to negative 4. Now, one thing that you'll find about log problems is that sometimes you'll solve them, and just like with radicals, you'll have extraneous solutions. And that's the case in this situation. You always have to go back into your original equation and make sure that 9, when you put it into either of the logs, doesn't give you something undefined. Okay, and 9 is fine, right? So if I put 9 in, I've got log base 6 of 9 minus 5, or 4, and that's fine. And here's just log base 6 of 9. But if I put negative 4 back into the equation, I've got log base 6 of negative 9, right? And log base 6 of negative 4. Now, one of the things you know from Khan about logs is you can't log a negative number, right? Because that's really like asking, well, what exponent would I put above 6 to get a negative 4? And you can't raise 6 to any power to get a negative number. So we have to throw out x is equal to negative 4. So the only real valid solution is x is equal to 9. Hope that helps on a tricky problem.